Hello? 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 Is it working, right? Awesome. Okay, great, great. All right, so let's go ahead and get started. Hello, everyone. Thanks a lot for coming. I'm really glad to see you guys in the beautiful day, Friday afternoon. Thanks a lot for taking time to come to our events. So before we get started, just kind of like a quick introductions about the events and what we do and some of other community updates. So um, so for today's event is a community, Carols Community Day series. One of the events we host in many cities around the U.S. And yesterday we are in New York, and the day before yesterday we are in Boston, and also in Austin. And next week we're going to go to the East Coast. So there's some of cities listed here. If you have friends, colleagues, and many of them right now probably still working remotely, you can share the event to your colleagues. They can come to the cities they are to join the event. So basically for the event, we are collaborated with the Google Develop Group called GDG. They are Google developers communities. They host a lot of events working with the communities, bring the Google technologies and open source technologies. Actually, Keras and TensorFlow, they are open source one. So they bring this open source technologies, Google technologies to the communities to educate, getting together to learn AI and machine learning. And AI Camp, we also are communities. So we right now we have more than 250,000 members in more than 150 countries. Also in many cities we have the chapters or local study groups. They are hosting the events. Pretty much most of the major cities around the U.S., Europe, and also Asia Pacific regions. Again, if you have friends or co-workers, they are in those cities, they can join those uh, chapters. And a quick way to, we are looking for the community managers in many cities around the world. And if you are interested to working with us to build the community, to get in, host the events, to grow in the communities, let me know. And we do need a lot of volunteers, community managers to host a lot of events. If you are interested to speak to the communities, you can submit topics. And of course, we are looking for the sponsors to, for the venues, and particularly for today, I want to actually call out for the IBM. They are supporting these beautiful venues for the events. And if you have other events, if you want to host the events and want to collaborate, bring large audience to your event, we are also happy to collaborate. You can reach out to us or you can talk to me. So I want to since these are community events and is for the communities, by the communities, and we often setting a little bit times for whoever you want to share. If is anybody looking for a job, or if your team is hiring, or if you're looking for the open source, you're working on some cool project you want to share, and you can raise your hand and you can have the mic to talk a little bit. Is anybody want to, if you're looking for a job, or if you're looking, or your team is hiring, anything you want to share, you can raise your hand and I will pass the mic to you. Okay, the one come for the one, you want to come up quickly? Did you raise the hand? Oh, okay. Okay, then you're next. Too bright.
Hi, all. Nice to meet you. So, my name is Gabriel, and I'm about to graduate in December from Masters in Computer Science. And I'm very interested in working in machine learning, AI, deep learning, NLP. So, I'm applying to jobs right now, looking for a job in this field, mostly in the United States, because I come from France and I did engineering and master's in ECE in France. But I decided to come here to get my master's so I can have a visa to work in the US. So that's about it.
Okay, cool. We all go through the process. So anybody else? Okay, come on.
Good afternoon. My name is Joseph. I'm a retired Marine, and I'm actually a college professor with a couple of advanced degrees. And most recently, I got admitted to the Georgia Tech Online Master of Science program, the CS program, with focal machine learning. So I'm teaching machine learning, learning machine learning, and attempting to find my next opportunity. I come from a cybersecurity background for 25 years. And so one of my PhDs in data science, the other one I'll finish is in critical infrastructure. For the story, I'm going to network, learn, share stories, have fun, and look for my next opportunity.
Great, thanks. By the way, later on you can also post that more details, your resume, or you are looking for the job openings to the Slack. So you can scan this QR code, go to the Slack, join the Slack, and looking for the Chicago channels. For each of the cities, we have the channel, so you can post more details in there. Anybody else? All right, so again, later on if you have something come up, you can post into the channel. I think that's all what I have. And today we're going to have Dan, and he's going to talk about Keras and the other AI topics. Without further ado, let's welcome Dan.
I will take a minute. Can we see the screen? Yeah. Hey guys, so my name is Dan Goncharov. I am GD in ML, Google Developer Expert Machine Learning. I don't work for Google. Google flies me to places, right? They believe in my expertise. I'm also visiting lecture at Stanford. I teach immunology students large language models. Okay, so today's topic is Keras. Keras NLP in particular. Modular NLP workflows with Keras NLP. Okay, first of all, what is NLP? This is your traditional definition of NLP. Natural language processing is a subfield of computer science and artificial intelligence focused on enabling computers to understand, interpret, generate, and respond to human language. Great. These are some examples of the tasks. There is machine translation, text summarization, question answering, sentiment analysis, and text generation. But I would argue that all these tasks can be framed as text generation problem, text to text. And we'll go through it a little bit later. Okay, cool. So there is some history of NLP. Probably the first would be in 1950. The Turing test appeared. 1960, there is ELIZA bot, therapeutic bot. It basically repeats same questions, same sentence that you told it, but in the question form. Now in 80s we have machine learning, first machine learning, and there is internet boost, and that gave us big data, so now we can train things. And in 2000 we have actually deep learning applied to NLP problem. Now a little bit closer to us would be 2016. There is Google Translate model, which was sequence to sequence model. 1719 there is OpenAI GPT-2, GPT-3. 2019 there is BERT. Multitask model, and last couple of years there is these huge models, GPT-4, Google Bard, Anthropic Claude. Okay, awesome. So moving on to the Keras NLP. Keras NLP, what are the features of Keras NLP? Keras NLP is built on Keras Core. This is the latest version of Keras. It will become Keras 3.0 after beta testing. The cool thing about Keras Core that you can have multiple backends for the Keras. It can be TensorFlow, it can be JAX, it can be PyTorch. There is also module components with preset ways and architectures that you can mix and match. And the highest modules are layers of models. By the way, guys, if somebody wants slides, just hit me up later on LinkedIn. I will share with you. You don't need to take picture of each one. There will be a lot of slides. Okay. So this is features, the benefits. There is full development cycle support because there is TFX support for production. Easy customize, and there is no costly migration between the frameworks. You know, you can mix and match PyTorch, JAX, and TensorFlow. And this is the reasons why would you want to use Keras. Multi-framework compatibility, modular and customizable, Keras familiar. So if you know Keras, Keras NLP is very easy for you. Cool. Okay, so what can you do with Keras? The coolest thing with Keras that you can go with, starting from very simple examples, just inference with pre-trained classifier, down to more and more and more and more complexity, up to build your own and train your own transformer from scratch. And we will go through examples. We'll go for some code today. Okay, so components. What components does Keras NLP consist from? I'm sorry. So there is tokenizer. What does tokenizer do? It basically converts your string, your words, into the tokens, into the integer numbers. If it needs to, for example, it will break up the words, and there is example how it will break the quick brown fox into the series of tokens and numbers associated with it. Next, this is how it use. So this particular case, we just load in existing tokenizer that already been pre-trained, Roberto-based English. Next level of abstraction would be preprocessor. Preprocessor use tokenizer, but also does some extra operations on our string. For example, it will put start and end token. For masking operation, maybe it will mask some tokens, and it can also do some things just to improve the performance. It could cache things, it can do multi-threading and so forth. This is where you put your logic in preprocessor. And this is how you use it. So in this particular case, again, we load up existing preprocessor. So next level of abstraction is backbone. Backbone is basically our transformer. It doesn't produce text, it produces the dense vector, basically embedding. So it takes the tokens, already encoded tokens, and produce the dense vector for us. And again, this is the simplest example how would you use it. Dense vector. Vector of float numbers, like 1028 float numbers, let's say, array or list. This would be dense vector. Yep. Multiple things, but we'll go through it a little bit later. There will be code. Yes. So first of all, there is quite few tokenizers available via Keras. You can just load them up, and you will look up what model are you using, because they need to be compatible. Your backbone and your tokenizer, they need to belong to the same process. And more than likely, you will just use the Keras pre-existing tokenizers. But obviously, you can train your own, and I will show it to you a little bit later today. Okay. So that's their flow. This is what I suggest. So I know for sure that you can load the models from PyTorch easily into the Keras. and then use, TensorFlow, for example, a bit later. I'm not sure if you can do same thing for tokenizers. If you can easily mix and match tokenizers. Right, but you usually don't want to mix them, right? Because you will break whole pipeline. The model and tokenizer need to belong to the same process. Okay, great. So, and this is the highest level of the abstraction. This is the task, and there is a few tasks, types of task available. One of the most obvious one is, classifier task. There is causal language model. There is mask language model, and available. There is about I don't remember. I think about 40 different available that you can load up in presets. Okay. And this is how would you load it up, very easy. So this is example of the component BERT classifier. BERT classifier is high level of abstraction, and it consists from few components. There is a BERT backbone, there is BERT preprocessor, and BERT preprocessor has a BERT tokenizer. Yeah? Okay. So we will look at few examples, few code examples. So in order to use Keras NLP, this is what we need to run first. For example, we run it in Colab. We would upgrade our Keras to Keras NLP, make sure it's installed, and we will define the backend. And it can be anything. It can be JAX, TensorFlow, Torch. Next thing that we'll do, in our particular example, we will look at sentiment analysis as example. So we need to load the data. We pull the data, and we use the Keras to split the data set into the train and test data set subsamples. And this is the code. So super easy. These 2 lines of code already produce for you results. You're not training anything, you just use the weights, right? So we, in this case, we pull the weights for BERT tiny uncased, and we do the prediction on this model. In this case, we put the string in, iLife modular workflows in Keras NLP, and here's the result, the array of labels. So apparently it's positive label. That's one example. Another example, next line is using IMDb test to evaluate our classifier. Loss is 45 and categorical accuracy is 78%. Great, so this is the easiest way to use Keras, right? Just 2 lines of code. Now let's increase the complexity. The next level of complexity, we will fine-tune it, right? We will fine-tune it on the data we just pulled. So again, we pull the BERT classifier, the weights, and we fine-tune it on IMDb train. It runs for 1 epoch, and our accuracy is already high. It's 87%. Awesome. So next level of complexity here, we will change the preprocessor. We will change the preprocessor. We defining the preprocessor, so we at first pulled it and then slightly changing it. We changing it so it will prefetch and cache the data, so it will run fast. And here's the results. Very similar results. Okay, next level of complexity, maybe we want to change the model. Right, maybe we want to change the model. Again, we did same thing as before. We pulled, let me highlight some things. So here, we pull in the model. Here, if you can see, we're saying that backbone trainable is false. Oops. Backbone trainable is false. And then we add couple more layers. Right here, do you see in the loop we put on 2 more layers? Okay, great. So we compile it, and we will look at summary. So there is line of code that says a model summary before the model feed. And this is what be the summary of the model. Do you see there is 2 more layers being added? Transformer encoder 1 and 2. So backbone is not being changed. Transformer will be changed during the fine-tuning. So next, if you notice at the end, there is a fine-tuning, right? Model feed. It compiles, it fine-tunes, it's working. Great. Okay, awesome. Next level of complexity. Next level of complexity, we train our transformer from scratch, right? In this case, by the way, they pull the tokenizer. I believe we training tokenizer here, and then we define the preprocessor. Define the preprocessor for this tokenizer. So we'll have start, end, and padding token supply. Here we will define the layers. It's tiny transformer. There's only a couple layers, I believe. And let's look at model summary. What will happen? So this is the architecture of our transformer. It's tiny, it's only 39 megabytes, but it compiles and it trains. So that's it. That's Keras NLP. That easy. I'm done at that part, but I want to jump to the next part. And it's, I mean, we can talk a little bit about Keras NLP right now, but next topic would be just a large language models, foundational models. What else can we do, right? And different tips and tricks. Why do we care about Keras NLP? Why do we need to train our models? Because, you know, BARD, GPT-4, Claude exist. Yes, question? One more time. Excellent question. So in these examples, we were pulling weights. Existing weights. I won't be able to find right away, but there's about 40 different models. I believe the largest models available, don't quote me, but I think it's about 7 billion model. On the top of that, you can add your own layers, you can train your own layers. And later today, I will look at parameter efficient fine-tuning. How can you deal with Llama? How can you load this, 70 billion parameter model and so forth? Keras NLP? Yes, Keras is completely open source. Yep. Yes. Great question. So first of all, it was just toy example. I did not care about the results, but if you want to do that, you don't want to overfit. So you will see the results on your train data and test data. And as soon as you see that your test data, the performance is decreasing, maybe it's time to stop, right? But you also need to smooth out this training line because probably you will have some noise. Probably your data will be noisy. Yeah? That's right. Yes? Excellent question, and I don't have an answer for you. I don't have an answer because they're different systems. They somewhat competing, but they're very different. For example, the main advantage that you have here that you can easily switch the backends. They can switch, JAX, TensorFlow, and PyTorch on the fly. Hugging Face doesn't have it to my knowledge, not that easy at least. 7. I mean, we can Google it right now. We can find it, but I think so it's not just one model, right? It's like a system. And there was good question about Hugging Face. Usually most of these models, de facto they are being, uploaded to the Hugging Face. And you can look up, which company is actually uploading. What's their reasoning? Why do they do that? I don't know. It's up to them. We know that, largest model available right now, I don't think it's even Facebook, Llama 2, the biggest model. I believe it's Falcon by Saudi Arabia or Emirates, 180 billion model. I believe so. Don't quote me again. What's the reasoning? Why do they do that? That's up to them. I can't explain that. I would not look at Keras as a model. It's not a model, it's a library. It's available through Keras domain. So I didn't do that yet. I cannot, tell you for sure, but you should be able to load other models into the Keras. I don't have example for you today how to do it. It's just a library. I believe so. It's just a library, like Python is just a language, right? There would be different code because this code uploads from Keras repository. You would need to upload from probably Hugging Face repository. True, but what you're looking at probably like last year, right? This is Keras Core. It came out only a couple months ago. But they're supposed to be compatible. Yeah? Moving on? Cool. Okay. So, foundational large models. Foundational large models, and I would like to go at first through 3 different models. Let's go back in time. Let's go back in time and probably it will clear up some questions. So back in 2018, there was a model by GPT, by OpenAI called GPT, about half a gigabyte, 120 million parameters. It was a general pre-trained transformer. And this is how we would use it, right? Do you see the green part? This is the transformer, basically, backbone thingy that we talked about before. And this part, do you see multicolors? Start, text, extract. This is what the pre-processing does. So the start, it's the start token, then you have the text encoding, then you have extract token. This for classification. And then you just slap the linear label on the top of that. This is where you would do fine-tuning for your particular task, right? Similar thing for entailment. Now you have, 2 chunks of text you put in, but you separate them by tokens, start token, delimiter token, extract token. And again, you have linear layer. And, approximately same idea for our tasks. So this is how things used to be done back in 2018. Now, in 2020, we have T5, 11 billion size model by Google. And the coolest thing that they come up with, that all these problems, they're actually text-to-text problems. You can frame them as text-to-text problems. So for example, for translate, you just put this custom prompt in front. Translate English to German. That is good. Das is good. There is caller sentences. The course is jumping well. Answer is not acceptable. So this would be the input. On our side will be the labels. And that was great. Why it was great? Because at this moment, you don't need to do machine learning engineering anymore. You just need to, cook your data in a certain way. Prepare your data. Great. So we're going further, and now there is GPT-3. By the way, I probably should increase it. So, and it says that paper that was associated with this model was language models are few short learners. Great. What does it mean? What does it mean few short learner? Few short learner, this is how you would traditionally fine-tune, right? There's input, output, input, output. You change the gradients. What if you don't need to change the gradients? What if you can do in-context learning? So to this model, you just need to show example. 1 example, or 2, 3 examples, and now it understands what you need, and it'll just produce the answer for you. So you don't need to change the model. So this was revolutionary back in GPT-3 then came out 2020. And it's not just that. There is more to that. More to that, that apparently there is also emergent abilities of these very, very large language models. It starts performing things that it haven't been trained for. Nobody created the special tasks. So this paper came out by Google 2022. They did some experiments on Palm 520B. So this is the phenomena. There is few examples of different tasks. For example, at certain size, it just becomes to be, math proficient. It becomes to do math operation or word and context task. But this is kind of boring tasks. My favorite task is emoji movie. Emoji movie, you describe the movie as a series of emojis, right here, for example, and you asking it what movie it is. And this is how it performs. You see there is a huge spike at the end. So it's not able to produce a correct answer. But at certain size it can. So if we'll go in details, this is the question, what movie does this emoji describe? And there is some Unicode symbols, 2 million, 16 million, 50 million, 1 billion, 2 billion, 4 billion, 8 billion, 27 billion, it's all garbage. This is not a correct answer, right? But all of a sudden we get to the 128 billion, and that's a correct answer. So it's emergent abilities. We don't know what it can do, but we can find them. And this is interesting, because again, we didn't train for that. There is no fine-tuning process. It's all, autoregressive task. Just predict next token, that's it. And again, it's one-shot learning. We are not changing model. Awesome. My next question, and just to see how hard is it, what machine sees, what model sees, it just sees numbers, right? If I will ask you this question, what movie does the module describe? It would be in numbers. You probably won't be able to answer because you don't have these priors. You haven't been training in this way. And if I will ask you in this question, probably it would be much easier, right? That would be fine in NEMA. Cool. Moving on. My next question is how large are large language models? What size? What sizes are currently there? And let's look at the history, at least some models. So 2018 BERT was 340 million, GPT-1 100 million, GPT-2 1.4 billion, GPT-3 170 billion, Jurassic 178 billion, Palm 540 billion. And these numbers are based on rumors. We don't know precise numbers. It's supposedly some leaked data. The GPT-4 it's about 1.7 trillion, and Palm 2 is about 1.3 trillion. So this is huge. This is huge. I mean, people kind of answered this question already, but I will still ask it, what can we do? How can we compete with it? We cannot train, 1.7 trillion model, but we still want results. Okay. And interesting that this thing came out. It was back in May, but I still want, to put on screen. It's supposed to be, one of the Google engineers leaked memo. We have no mode, and neither does OpenAI. And it's interesting that, things that he put behind in this memo, and we can look through them, because some of them make sense. So this was back in May, and this is when Llama was published. Llama was published a few weeks before this paper. And what they showed that 2 weeks apart, 1 week apart, this was improvements on the models done, different way improvements. Why? Because this model was given to the community, and people were able to actually play with it, right? So it wasn't just Google engineers or OpenAI engineers. It was whole community what was very passionate, and they did the results that we expect to have like in 3 years. We got it only in few weeks. Now let's see how it's done. One of the points, this guy is claiming that data quality scale is better than data size. And to back it up, there is actually a couple papers available. Couple papers. One would be by Microsoft. It's Tiny Stories. Tiny stories is synthetic data set of short stories that only contain words that typical 3 to 4 years old usually understand, generated by GPT-3, 3.5, GPT-4. We show tiny stories can be used to train and evaluate large language models, not large, just language models, that are much smaller than state-of-the-art, below 10 million parameters, and have simpler architectures, yet still produce fluent and consistent stories with several paragraphs. So that's one paper. And there is another paper, textbooks, all you need. So here we also create the synthetic data, but we also select data much better. So these two papers show very good results, that you can have smaller models but better data, produce similar results. And now we get into the how can we train on the smaller models? Because when you train on large models, even for large organizations, it takes a few weeks. I believe BART is being fine-tuned every 2 weeks or so, because it's a very large model, takes time. You need to have a lot of iterations if you want results, and you need to do something better. And this is where LoRA comes in. And then, instead of spending a few $1 million, you only spend about $100, like one GPU, and able to fit the model. And we'll look what LoRA is. LoRA is low-rank adaptation of large language models. So they're bragging about that they're able to reduce the number of trainable parameters by 10,000 times, and GPU memory requirement by 3 times. And that's awesome. That's big, right? So how does it work? So this is your traditional fine-tuning. Right, you do the pass, forward pass, and then you do backpropagation. You do backpropagation and you update the weights. This is traditional. And this is how, it's the same thing, just, different representation of the same process. So what we can do matrix decomposition. We can do matrix decomposition, and this way, so it's not exactly the same. It's already some approximation of original matrix, but size is so much smaller. Again, 10,000 times smaller. And this way we can fit it on a single GPU. But we don't stop here. There is a next paper, interesting paper. It's called QLoRa. QLoRa does LoRa plus quantization on the top. Quantization, it was able to fit, 65 billion parameter model on 48 GPU, a 48 gigabyte GPU, and that was huge. So it does quantization. I believe it's QLoRa currently available through Hugging Face, but weights need to be quantized before you do anything. Yep, and now we move into the next subject. Next subject is prompt enrichment, right? What else can we do? What else can we do with our large language models? Maybe we can pull data. Maybe we can enrich our prompts. And we'll do it via information retrieval systems. And this area is not young. It's kind of old. It's at least 30 or 50 years old. So why do we need it? For a few reasons. First of all, if you do RAG, retrieval augmented generation, you can find hallucinations. You can find hallucinations because now you can ask for references. Then it makes the statement, you can ask for exactly what chunk of text produced this kind of conclusion. It can do that. Second, as you know, GPT-3 is a couple years old, cutoff time or something like that. And also, maybe it just doesn't have access to the data that you need because it's your own proprietary data. It doesn't know who you are, but you want to tell it. And another aspect that maybe you're working with data that is large, like very large, and you cannot fit it in input window. Maybe it's a set of documents. So you would chunk it up, find the relevant, and you would feed it via the system. Okay, so how to do the information retrieval? This is one of the oldest, TF-IDF. It's term frequency inverse document frequency. It basically, keyword search. It's one of the oldest. Results are worst, but it's computationally light. You can do it very fast. The next level of complexity would be embedding space. Embedding space, as we talked before, there is backbones, right? There is backbones, and you can take your chunk of text, you can feed it through the backbone. Now you have embedding, and now when you're looking for relevant information, you can look for nearest neighbors around the zone, right? In this space, I don't know, 1000 dimension space. And probably you will use cosine similarity to calculate the distance, one of the most popular methods. This is embedding based. Next level of complexity would be neural ranking. Neural ranking, we can actually, this is Siamese twins, but we don't have to use it. We can use just, your regular BART, your regular GPT-3, GPT-4. You can give it 2 chunks of text, and you can ask how relevant these 2 chunks are to each other, right? And ask for some kind of number. So this will be neural ranking point-wise. And there is also pairwise. Pairwise comparison, like there is somebody's suitcase here. If I will ask you what's the surface of this microphone, how many square inches, ask you for number, you will give me some answer, right? If I will ask you a different question, like which one is bigger, this would be much easier question, right? It's much easier to answer. So if I will ask, which piece of data is more relevant, piece of A or piece of B, it's actually easier answer, and you provide better results. Only problem that now you have to have all the permutations, and it's costly. So what do you usually do in ideal scenario? You have this funnel system. You have the funnel system, the keyword filtering at first, then embedding search. Second stage, third stage, you will have point-wise neural ranking, and last stage will be pair-wise ranking. And after that, you have this golden dot. Out of the 1 billion chunks, you had 10 chunks that are actually relevant to your question or to your task. Usually it's a question. And you will just put that inside of your input, because your input is always limited. It's big, but still limited. Yep. So that being said, there is you don't have to do it all from scratch. There is a couple products available. There is ChromaDB. It runs right on locally on your computer. There is Pinecoin AI, runs on a cluster, so you can put any size of that you have, any database. And Google provides also its own solution that will be vector search. Used to be Vertex AI matching engine. Awesome. Awesome. Now I want to introduce this paper. This paper called Frugal GPT. Frugal GPT because, again, back to the question, why do we need to train our own models? We already have these huge models, these wonderful models. So, for example, this paper claims that by using some of the tricks, you can provide either much cheaper solution, 98 reduction in cost, or solution that's actually high in accuracy than GPT-4. There is few tricks that they use, but I think one of the most valuable is large language model cascading. Large language model cascading, then you're not just taking the answer from the model, but somehow you also estimate the scoring for this answer. Is it a good answer or bad answer? You can do it a couple different ways. Right out of the bag, you can use calculate the probabilities of the answer. But now one better one is actually to train separate model. Separate model that would be model discriminator, model judge, that will look at question and answer and provide the scoring for you. So in this particular case, do you see this is the sizes of the model. GPT-J is the smallest, GPT-3 is bigger. GPT-J is basically free for them because they run it locally. GPT-3 is bigger but cheap, and GPT-4 is most expensive. So then they get onto the GPT-3, apparently scoring is already good enough and they don't need to go to the GPT-4. So this is one way, right? So this is where you would plug in model that you train model that's smaller, but maybe it's still good enough, because again, there could be, hard questions and easy questions. Maybe you don't need to use super large model on easy question. Another approach is routing. Model and prompt routing. It's implemented via, there is implementation in the LangChain, but you can do it yourself. So basically, you train multiple models that will have expertise in different domains, in different subjects. And then you have the question and you have a query. Different model, router decides where should it go, which model should answer this question. And this way you provide the answers on par with, super large models. And that's it. Questions? No? I tried. Yes? So most naive solution, you train different model. You train model dispatcher that will come up with answer which model should you route it to. That's, I guess there could be even easier solutions that you do keyword search, but I would argue that probably won't be good results. It's better if there's a little bit more understanding. They're not that heavy, they're not that hard to compute. So this is bad example, but still it won't prove the point. But there was a reflection paper. Reflection, yes. The reflection paper, different prompts you can ask model perform in different roles. So you just, by changing the prompt, asking, be the judge, and what the answer model still can produce it. Only problem is that probably your model need to be on a bigger side. This is what the diagram. So this self-reflection, actor, and evaluator, it's all the same model, just different prompts. Who's next? Any more questions? Routing. Yep. I'm sorry. English is my second language. I shouldn't correct you. Yeah. Yeah. Yes. Yes, it's concept of agents, right? Like same as humans. Like the different agents, different humans have different area of expertise. And some of the agents have expertise in management. So it's a model manager. Yeah. Yes. So hallucination is very hard problem. Hallucination is very hard problem, and we can look at how humans deal with hallucinations. Because whatever I'm telling you right now is my opinion, right? You can trust me or not. It's just my opinion. What can I do in order, to prove to you that this opinion is correct? I can pull some references, right? I'm pulling the papers right now. I'm putting them on the screen. That it's not just my opinion; it's opinion of other people. That's one. So you can via retrieval augmented generation pull the references for the text, what it's being produced. That's one approach. Another approach, same as in scientific community, for any question, you actually can have multiple answers. There is, scientific consensus, right? People don't always agree on the same subject. So you can do same thing here. You can have multiple models or even same model, but you will ask it, do you see, there is limitation. We think that we can use model only once or twice. The AlphaCode paper by DeepMind, they ask model question 1 million times. 1 million times, and then they do clusterizations of answers. They look at these clusters, and each cluster is opinion, 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 and it showed that clusters of larger size usually correlated with correct opinion. Yeah. More questions? Yes. No, very good question. Very good question. So again, there's different use cases, right? Like I love to use ChatGPT because English is my second language, right? I like to, to check my email so it will sound correctly. So I will just put it there and, ask, please fix my, my message here. And answer it will produce, I'm fine with it. I don't need to have references, right, for this use case. But if you're asking very particular information, I don't know, biomed information, then probably you want references, right? Then you yourself cannot judge the answer. Because again, another cool thing that it's easier to be discriminator, it's easier to be the judge than generator. Yeah? Any more questions? Yes, this is the approach, only you don't do it once, you do it at scale. And small problem is that how do you compare that two pieces of text is actually same information. So you need to have special, algorithm that would clusterize these, three answers as actually one answer, that it's actually same piece of information. And these two answers are different, answer. So for that, you probably will use embeddings. And our approach is, at least for programming, you can come up with unit tests and you will push the unit test through the code, and input and output data will characterize, do they belong to the same answer or different answer? Yeah? I didn't see quantization. Yes, I think I saw quantization example and I saw LoRa example. Yes, just a library. Nothing stops you. Yep. Can you give me an example? So then you train your discriminator, right? Your judge model. You do have golden data set, then you know correct answers. And you know that on this data set it produces, good enough value. Whatever, cutoff value for you is. It's 80% of accuracy, 90% of accuracy, you decide. And then based on assuming that, next piece of information is in same domain, trained in same domain, same language, you can assume that it will produce same results, same quality of results for judging things. Now, where's your cutoff? There's your threshold happens, scoring 0.7, 0.8, 0.9. That's up to you. This is hyperparameter tuning problem, right? Again, you have golden data set, second one, and you try in different values. So first of all, this is kind of two different approaches. The example that I talked about, 1 million predictions coming from the same model. Okay. PageRank. Right, so let's put some things on the screen so it would be easier to communicate. Yes. So this is concept of GAN. GAN images. So you have, I'm trying to find something good. Okay. So there's PageRank, but it's a different problem. Understood. So there is actually two different problems. You asked me about LLM cascade approach that, been represented in Frugal GPT. I can talk about that. If you're talking about label, GPT-4 doesn't provide the scoring. There is no scoring in GPT-4. It doesn't do that thing. You can do that. You can do it on the top and you will improve the results. This is what Frugal GPT did. They were able to bump up the score. Then they introduced the judge to the answer. Because you can, it's not just one short operation. I just ask the question, there's an answer, that's it, I stop. You can do it iteratively, right? You can take this question answer, now you feed it as a prompt, but you put, question, do you think it's correct? Give me the scoring. And you can do it multiple times. You can do it not just 2, 3, 4, 10, 100, 1,000 times. And now you will have consensus. You will have these clusters with scoring attached. So this is the, for GAN, generator adversarial network. It's for images. Also, something that doesn't have clear value, but it works. So there is model that is generator and model that discriminator. And it's been proven that quality of images are much higher this way. It's just a concept, it's an algorithm. Yeah? True, but again, right now, things that I'm saying is just my opinion, and you do believe me, right? It's up to you. Do you believe these answers or not? If I did see in my everyday life that I'm talking to this entity, and most of the time, 90% of the time, or 95% of the time, the answers are good answers, I will value this system and I will use this system. Same as your coworker. You probably separate your coworkers, smart and not very smart, whom you take advice or not. Yes. 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 You can. You can. It's called chain of thought. It's very good method. It's good that you brought it up. It's actually improved the results greatly. You can ask the model at the very beginning, give me the answer, but explain step by step. Why did you do that? And it will explain by step. And usually results are much better. Yep. So there is a chain of thought, the original one, and then there is a tree of thought. I'm not going to go through these papers today, but look them up. Not always correct, but quality improves. Yes. So if you build a model for your company for very particular task, this is what I would recommend to do. But since OpenAI goal is building AGI, general intelligence, they want to build system that understand, all areas of expertise. It's proven that, GPT-4 can pass the quantum mechanics exam. It can pass the, legal bar in certain state. It can pass, medical exams and so forth. The horizon of skill is very wide, and we appreciate that, right? We come every day with different questions. They ask us questions, and most of the time we get answers. It would be nice if there would be also confidence attached to these answers. I agree. I would feel more comfortable if it would tell me that I'm 50% sure, 70% sure, or 90% sure. I think it would be an awesome feature, but I think Google start doing it. Google start doing in a BARD that there is a second operation. Then they will run against of the Google search and find all the references for all the statements that BARD made, if they're true or not true, consistency. So that would be, I guess, next stage. The retrieval augmented generation. True. Only problem is that it comes from the model itself, and sometimes it hallucinates this reference. If you will Google them, sometimes they're lies. the BART system, it's actually two different systems that produce, the original answer and then the references, the snippets. Whereas else on internet, somebody else has same opinion as this particular snippet of text.
How do you assess those references? Then again, you have to analyze by text.
If you want to, if this is important for you.
You have to start with reference, or you have to use again some more specific older frame based head that you want to try to provide to, meaning it's kind of right.
What is the truth? What is the truth? Again, it's not certain topic. Like big example is COVID. To wear masks or not to wear masks, right? Opinion changed. So what is the truth? You cannot have definite answer that this is the truth. It's opinion, it's consensus of many people right now that this is the truth, but maybe it's not. So no, I don't believe that there is zeros or ones. My opinion.
But that's inherently true for any sort of information.
Yes.
So even books are biased, right? So if you're even the papers you're referencing might have some biases, which
True.
other papers down the say 5 years down the road, someone would write to refute some paper, right? So it happened to Einsteinian theories too, right? So that's yeah.
It comes back to evaluation. And they're also evaluation.
Sure. I mean, yes, and now evaluation data sets improving over time. They become bigger and bigger, and evaluation algorithms also changing. Like for large language models, it used to be, at first, did you see this word? How many times did you see this word in a, correct label and your answer? So it was just based on, trigrams and bigrams. That would be Roche, Blue score. It's kind of like keyword based. But nowadays you do better. You do BERT score. You actually have another transformer that evaluates this answer, because does this answer has same meaning? Maybe it has completely correct, different set of words, but it's exactly same meaning. So yes, we improve on this, but I don't think it will ever be, 100%. We ever be perfect. We strive for that. Yeah. OpenAI. Yes, GPT 3.5 available for fine tuning if you want minimum, engineering effort. But if you want to have it on your premises, maybe it's private data that you cannot give to OpenAI. Maybe you will do it on your cluster. Yeah. Sure, we are here for that.
real world stuff, more emphasis on smaller, more specialized, but trained model specialization came together rather than all this hype going about. So interested in the next big LLM sort of starting to wane and black start to think about the cost actually are you small enough out.
Got it. So, first of all, I'm a huge fan of LLM. I don't like when people say hype. Hype is something that doesn't have value. There is value in this thing. I'm using it every day, okay, for different applications. Okay, that's fine. Second, your question is sensitive to the use case that you have. Like, for example, if it's a customer support bot, right, chatbot, the GPT-4 will be doing just fine. Just, make sure that you have this reg attached to it so it feeds on your company data or documentation that's publicly available. It's fine. But if it's, I don't know, some kind of transactional data that only you have in your database about your customers, I don't even know what the example is. I don't know, ad tech, advertisement technology, right? That maybe it's not even words, maybe it's just, some tokens, IP addresses, some numbers and so forth. And yeah, sure, you should train your own model. Depends how much is out of the domain, how specific is your use cases. Is it pretty close to just regular natural language or it's very far away? And again, many times, companies are afraid to give their data anywhere outside. And for that, yes, you will train your model. And no, you're not going to train, 1.7 trillion model. You will train smaller models. Yeah? Any more questions? No? We're good? Awesome. Thank you.
All right. Thank you so much, Ken, for the great presentation, and thank you all guys for the great questions. Let's give a round of applause, please. Great. So we're going to do next one is let's do finish our the last items on the agenda to the lucky draws. And if you have not entered the raffle yet, this is the last minute to enter the raffle. Basically, scan the QR code and make comment on the linking post. And I will start to draw in 30 seconds. Let me just quickly set it up. And by the way, the price is the Google Home. So you can use it to set an alarm to ask for the weather and also a lot of other cool functions. All right, so let me do the okay. I got about some entries here. Let me copy it over here. The name is not here. Okay. Did you comments on that? Okay. So if you're before school. Oh no. So if your name is not here, and come up here to type it. Sometimes just come here to type it. It's easier for me to, because sometimes linking, they are using the your profile have some settings say private.
Yeah.
with that one, we don't have a permission to get your name. So that's probably the reason. To enter first. Yeah, to enter.
Bajámoslo con el intro.
All right, one more. All right. Did we miss anybody? So we all got it. All good. All right. So about 15, and the odds is pretty high. So there we go. 1, 2, 3. Go. Gabriel, do we have a winner? All right. Okay, great. Congratulations. Well, with that, it concludes today's event. Well, thanks a lot for for your coming. And if you have questions, want to hang out here, I think we have some times in the meeting in the room here. Feel free to ask questions to discuss. And also check out our website for the future events. And we, particularly in Chicago, so we want to run more community events on AI machine learning. So at least like once a month, we do need your help with, we are looking for the community managers, looking for the volunteers to helping us to host the events. And, we also need support to share the events to, to our friends, colleagues. So I hope to see you in our next event. So by the way, I want to thanks Ron for setting up the venues and to provide the venues for the events. Do you want to say anything or?
Sure.
Okay. And also for the recording things.
Thanks, Bill. And this is our second time we're doing this event in this newly opened facility. So we closed down this area and we're just reopened yesterday. So thanks. I would like to thank everyone for coming here. We used to do a lot of events. We would like to get back into some of these things. Maybe we can look into how we can collaborate more.
Absolutely.
And if you have some other ideas, just come to us. We're always open to new ideas and working with different communities and universities and other folks who have generated a lot of ideas. So yeah, just let us know, and then we're open to most things, not just AI, other events. We also do some executive level events. So, thanks. Thanks, Bill.
Great, thanks. All right, so yeah, feel free to hang around here